So you guys wanted this question from a practice test that's not really something we've talked about so far. So first I just need to give you an idea of what we mean by W of t as with a little vector hat, right? So this thing's a function probably, right?
Yeah.
Okay. If it's a function, it probably takes some blob and turns it into some other thing, right? This one specifically takes t's, right? And turns them into one thing. Turns them into vectors, right? You guys see that? And then what I know is that all those vectors are the same length. You guys see that? So what that would mean is, okay, here's some sphere. I'm going to say this sphere is of radius k, right? Then there's some function, right, that takes t's. This is the w of t function. And it turns them into some vectors. And the thing I know about those vectors is that they all end on the sphere. You see that? So that would sort of mean, right, that I've got a vector like this that comes up to the sphere. And then nearby there's a vector like this that comes up to the sphere. And so what I get is this kind of, some kind of wander around like this, right? That's all on the sphere. Yeah? Maybe?
What are you doing?
Okay, so I'm trying to explain this concept of a vector valued function.
Okay.
And this specific instance of a vector valued function has the property that all the outputs are the same length.
That's why there's a squiggly line in there.
So there's a squiggly line on the surface of a sphere, right?
Yeah.
So the sphere, and this thing, all the vectors are the same length, which means they're on the sphere. I don't know exactly where they go, but they wander around on the sphere a little bit.
Okay.
Okay, so what would a derivative to a thing like that look like? I mean, what information should that tell you?
Like a line, because...
Yeah, it should look like kind of a tangent line, right? Okay, so it should tell you kind of instantaneously, right, where's the green thing going? Perpendicular. And if I look at this kind of picture sideways, right, I've got my sphere after I rotate my vision, and I've got that vector that goes up to the surface. And then, of course, the tangent is someplace perpendicular to it. Do you see that? It's got to be perpendicular because it's moving along the sphere, right? So the derivative of it should be tangent to the sphere. Kind of make sense? We really haven't talked about vector valued functions before, so this was a hard ask on a practice test. Okay. Cool. But the geometry that's happening is you've got some little curve on a sphere. A tangent line to it's going to be tangent to the surface of the sphere, and that vector that goes there is going to point out from the middle. So you get this right angle. Cool.